You've seen them on the feet of celebrities, on city sidewalks, at football field, and now on shelves with the FIFA World Cup logo stamped right on the tongue. The Adidas Samba OG, a shoe born in 1949 to help soccer players train on frozen ground. A shoe that spent decades as a football staple, got adopted by British terrace culture in the 80s, and then quietly became one of the best-selling lifestyle sneakers in the world all over again. For the 2026 World Cup, Adidas took this icon and made it a collector's piece. Each pair starts as a raw hide and a slab of gum rubber and goes through dozens of hands before it lands in a box. If you're curious about what those steps look like, hit subscribe to Captain Discovery, and let's go inside the factory together to find out how Adidas made the sneaker that took over the 2026 World Cup. In the late 1940s, European footballers had a serious problem: winter training on icy, hard-packed ground. The boots of that era couldn't grip. Players were slipping. Performance was suffering. Adolf Adi Dassler, the founder of Adidas, decided to fix that. In 1949, he crafted a boot with a premium leather upper and, most importantly, an entirely new kind of outsole: a thin, patterned gum rubber sole that could bite into icy surfaces without metal studs. The shoe worked so well that players said it made them move with uncommon grace and fluidity. Over the following decades, the Samba evolved. By 1972, it had dropped to a lower profile and added a zoned outsole better suited for indoor soccer. By the 1980s, it had left the pitch entirely for the terraces. British football fans adopted it as part of their match-day uniform. Skateboarders claimed it. Runways borrowed it. In 2023, it was named Shoe of the Year at the FN Achievement Awards. And now, for the 2026 FIFA World Cup, Adidas has released the Samba OG in a special 4-pack. Full-grain leather uppers, suede T-toe overlays, gum rubber outsoles, and gold foil details. But behind every pair sitting on that shelf, there's a factory floor. And that's exactly where we're headed next. Every pair of Adidas Samba OG World Cup 2026 sneakers starts not as a shoe, but as a flat sheet of full-grain leather. The hides arrive at the factory already tanned and treated, but they still need to be graded. Workers inspect each panel by hand under bright overhead lighting, checking for any irregularities in texture, thickness, or grain pattern. Once graded, the leather sheets move to the cutting station. In most modern Adidas factories across Vietnam and Indonesia, precision die-cutting machines press pre-shaped metal dies into the leather with hundreds of pounds of force. In a single strike, the die cuts out a perfect component: a side panel, a toe box overlay, a heel counter. For the World Cup pack, each colorway gets its own carefully sourced leather. The Argentina and Portugal pairs arrive in suede. The France and Mexico pairs use white full-grain leather with red leather heel counters. Even the 3-stripe overlays in each colorway are cut from leather panels pre-dyed to match the exact flag colors of each nation. Once cut, every component is labeled and bundled together into a kit for that specific shoe. The kit travels as a unit through the rest of the production line. With the kit assembled, workers move to the stitching stations. The upper assembly of the Samba OG requires precision that automated systems alone can't fully replicate. First, the synthetic leather lining is stitched into shape. This lining is softer and more breathable than the exterior leather, and it determines how the shoe will feel against your skin. Once the lining is formed, the exterior leather panels are stitched on top of it, building the upper layer by layer. The three-stripe overlays are stitched onto the side panels with raised visible seams. Part function, part identity. Those three stripes aren't just decorative. On the original Samba, they provided light lateral support for the foot during side-to-side athletic movement. For the World Cup 2026 edition, one additional detail is added at this stage. The FIFA World Cup 2026 emblem is carefully stitched or heat-pressed onto the tongue of the shoe. Stitching a complete upper takes a skilled worker roughly 20 to 30 minutes per pair. Here is the step most people have never heard of, and it might be the most important one. The assembled upper is just a flat, floppy piece of stitched leather at this point. A shoe last is inserted into the upper. A last is a solid form, typically made from high-density plastic, shaped exactly like a human foot. Each size has its own last, and Adidas maintains hundreds of them in different widths and lengths. Once the last is inside, workers or automated lasting machines pull the edges of the upper down and around the bottom of the last, stretching the leather taut. The leather is steamed first to soften it, making it more pliable and allowing it to conform precisely to the last's contours. The edges of the upper are folded under the last and cemented flat to the bottom, a process called the lasting allowance. Workers check the alignment at every angle. A misaligned upper at this stage means a shoe that will look and feel crooked on the foot. While the uppers are lasting, another part of the factory is busy building what goes underneath them. The gum rubber outsole is produced in a separate molding process. Raw gum rubber compounds are loaded into heated molds and pressed under high pressure, forming the cup sole that wraps up around the sides of the shoe. The tread pattern on the bottom of the sole is baked directly into the mold, so every outsole comes out with identical geometry. Once molded, the outsoles are trimmed, cooled, and moved to the bonding station. This is where the cold cement process takes over, the method Adidas uses on every shoe from the Samba to the Ultra Boost. A worker applies a thin coat of primer to both the bottom of the lasted upper and the top surface of the outsole. The primer chemically activates the surface, preparing both materials to accept a strong adhesive bond. Then, a coat of polyurethane cement, a powerful, flexible glue, is brushed onto both surfaces and allowed to flash dry in a short heat tunnel at around 140 degrees Fahrenheit, 60 degrees Celsius. The moment both surfaces are ready, the outsole is pressed firmly and precisely onto the lasted upper. Alignment matters enormously. The three stripes on the side of the cupsole have to line up perfectly with the stitched stripes on the upper. A skilled worker handles this positioning, then sends the shoe into a hydraulic press that applies uniform pressure across the entire bond surface for several seconds. cold cement process produces a bond strong enough to withstand thousands of miles of wear. The shoe is nearly complete, but it still has to earn its box. The cushioned insole is pressed into the interior. Laces are threaded through the eyelets. For the World Cup 2026 Samba OG, those laces are classic flat white, paired against the bold colors of each nation's colorway. Then comes quality control, and it is not a formality. QC workers handle every single pair by hand. Shoes that clear QC are cleaned, stuffed with tissue paper, placed in their World Cup branded boxes, and staged for shipping. And here's something to think about as these sneakers make their way to store shelves across America. The same precision, the same material science, the same obsession with detail that goes into building a Samba OG, goes into building every piece of gear that shows up on the pitch during the World Cup itself. Speaking of which, those iconic jerseys worn by players from Argentina to France? They go through a manufacturing story just as fascinating. And the next time we step inside the factory, we're going to break down exactly how a FIFA World Cup match jersey gets made, from yarn to final whistle. Over 5 billion people are expected to watch the 2026 FIFA World Cup. And every single player who steps onto that pitch will be wearing a jersey that took 3 years and hundreds of engineering decisions to build. But here's the thing most fans never think about. The shirt on Messi's back isn't just sewn fabric. It's a micro-engineered cooling system, built from the ground up to fight 95-degree summer heat across stadiums in Texas, New York, and Mexico City. Today, we're stepping inside the factory to find out exactly how a World Cup jersey gets made, from a pile of discarded clothing to the most watched garment on the planet. The World Cup jersey has come a long way from its wool and cotton roots. Back in 1930, players at the first ever World Cup in Uruguay wore heavy, loose-fitting shirts that soaked up sweat and weighed them down. For decades, the evolution was slow. Synthetic fabrics crept in during the 1970s and 80s. And by the 1990s, polyester had become the default. But the real revolution came in the 2000s, when brands like Nike and Adidas started treating the jersey as a performance technology platform. Nike spent 3 years developing its answer, called AeroFit. Adidas fired back with ClimaCool Plus. Between just these two brands, they'll outfit more than 30 national teams and generate a slice of the global jersey market now estimated at $11.7 billion by the end of the tournament. Now that we know the story behind the jersey, let's get inside the factory and see exactly how one gets made. From a pile of old clothes to the shirt on Messi's back. Before a single thread is spun, Nike's supply chain starts somewhere most people would never expect. In bins of discarded clothing and factory floor scraps. For the 2026 World Cup kits, Nike made a historic decision. Every elite match jersey would be made entirely from textile waste through a process called textile-to-textile chemical recycling. This is a major departure from the industry standard, where most recycled sportswear polyester came from plastic bottles. Bottles are easy to process, but they don't produce yarn with the structural complexity Nike needed for AeroFit's precision knitting. So instead, workers sort through end-of-life garments, old jerseys, factory offcuts, returned apparel, pulling out non-polyester components like zippers, buttons, and seams. The remaining textile material gets shredded into small fragments and fed into a chemical reactor. The result is a feedstock that is physically indistinguishable from virgin, petroleum-derived polyester. This virgin equivalent material is what makes everything that follows possible. Without it, the stitch-specific computational knitting of AeroFit simply couldn't be achieved. There is no jersey here yet, just chemistry preparing to become performance. Once the polyester monomers have been recovered and purified, the next stage transforms them into yarn, the literal foundation of every jersey. The monomers are repolymerized into long polyester polymer chains, then extruded through precision spinnerets, tiny nozzles with holes finer than a human hair, to produce continuous filament threads. These threads are drawn, stretched under tension, and textured to give them the mechanical properties Nike needs: extreme elasticity, moisture-wicking capability, and the structural integrity to hold a tight, stitch-specific knit without fraying or distorting under athletic movement. On the Adidas side, a parallel process produces the yarn for their ClimaCool Plus system, designed with body-mapped ventilation zones based on thermal mapping data. The yarn comes off the spooling machines in tight rolls, each one containing thousands of meters of engineered thread, ready to be fed into the knitting phase. The facility at this stage smells faintly chemical, the spooling machines spinning at high speed in climate-controlled rooms to keep the yarn's tension consistent. This is where the jersey's performance architecture actually comes to life. Industrial flat knitting machines load the engineered polyester yarn and begin executing a computer-generated knitting program that varies stitch type, stitch density, and mesh structure zone by zone across the entire body of the garment. In high ventilation zones, the chest, upper back, underarms, the knitting machine creates open mesh structures where the loops are wider and more loosely interlocked. In structural zones, the collar, side seams, shoulder panels, the stitch density tightens significantly to provide stretch resistance and shape retention. A single jersey uses dozens of distinct stitch patterns across its surface, all calculated through heat mapping and motion data gathered from athletes during testing. The machine itself moves rapidly across the knitting bed, needles clicking at high frequency as the fabric takes shape. Now comes the transformation from blank fabric into the iconic national colors that fans around the world recognize immediately. For World Cup jerseys, brands use a printing method called dye sublimation, and it is one of the most visually striking stages in the entire manufacturing process. The fabric panels move through a large format sublimation printer, where specially formulated inks are transferred onto the textile using intense heat, typically around 400 degrees Fahrenheit. The result is color that becomes part of the yarn, not a coating over it. This matters for performance because it means the design doesn't crack, peel, or fade through repeated washing and hard use the way traditional screen-printed graphics do. For Adidas's 2026 kits, this sublimation process delivers the complex gradient patterns, lenticular logo effects, and body-mapped ventilation graphics that define each federation's design identity. For Nike's kits, the same process renders the Aero-Fit ventilation zone, patterns, national heritage graphics, and jacquard design elements that integrate directly into the fabric structure. The jerseys emerge from the printer vibrant and dry to the touch. What was gray mesh is now Argentina's sky blue or Brazil's dark blue. The printed fabric panels now move to the assembly floor, where skilled operators and industrial sewing machines work in tandem to construct the final garment. Collars are cut and attached, side seams are joined with reinforced stitching designed to hold under explosive lateral movement, and sleeve panels are set and sewn at precise angles to optimize a player's range of motion. For authentic match jerseys, tolerances are tight. Seam allowances measured in millimeters, stitching tension calibrated to prevent puckering in high flex zones. After assembly, the jersey enters the badging station. The Federation crest is applied using heat press technology that bonds the badge to the fabric at high temperature and pressure for a precise dwell time. Sponsor logos and competition marks follow the same process. The jerseys then enter the quality control line, where inspectors check every unit against a strict standards sheet. Color consistency, stitch integrity, label placement, and dimensional accuracy. Stretch testing verifies that seams hold under force. Any jersey that falls outside tolerance is pulled from the production run. Approved units are folded, bagged in individual polybags, and packed into shipping cartons destined for Federation equipment managers, retail distribution centers, and eventually, the locker rooms of 48 nations preparing for the biggest stage in world football. And if the jersey on a player's back tells the story of a nation's identity, then what protects a goalkeeper's hands tells a story of its own. Which is exactly why our next video takes us inside the factory where World Cup 2026 goalkeeper gloves are engineered, molded, and built to stop shots traveling over 80 miles per hour. A shot blasts off a striker's boot at over 80 miles per hour. It's heading straight for the top corner. And in a fraction of a second, less than half a second, a goalkeeper's hand shoots up, fingers fully extended, and the ball sticks. Game saved. World Cup dream alive. But here's what nobody talks about. That save wasn't just athleticism. It was chemistry. It was engineering. It was a pair of gloves built in a factory layer by layer, where the difference between a catch and a drop comes down to exactly 4 millimeters of latex. This is World Cup 2026. And today, we're stepping inside the factory to find out exactly how they make the gloves that guard the net. Goalkeeper gloves haven't always been this sophisticated. For most of soccer's early history, goalkeepers wore simple leather gloves, the same kind you'd shovel snow in. Grip was inconsistent. Finger injuries were common. There was no science behind any of it. That changed in the 1970s and 1980s, when manufacturers started experimenting with latex palms. Latex, a natural rubber compound, turned out to have remarkable grip properties, especially when slightly damp. By the time the 1990 World Cup came around, nearly every professional goalkeeper on the planet was wearing latex palm gloves. Today, the market has exploded. Global goalkeeper glove sales generate hundreds of millions of dollars annually. Top-tier match gloves from brands like Adidas, Nike, and Puma can retail for $130 to $140 a pair. And the elite versions worn in World Cup 2026 aren't just gloves. They're multi-component systems engineered with knitted backhand panels, anatomical flex zones, silicone 3D elements, and German-sourced contact latex that gets replenished with a few drops of water before every game. This is the story of how they get made. Everything starts with latex. Not all latex is the same. And in a World Cup goalkeeper glove, the choice of palm material is the single most important decision the engineers make. Professional-grade gloves at this level use what the industry calls contact latex, sometimes branded as Supreme Latex or German Pro Contact. It's sourced primarily from specialized manufacturers in Germany, and it represents the top tier of a four-category system: soft, super soft, mega grip or giga grip, and contact. Each level trades grip for durability. The softer and stickier the latex, the faster it wears down. Contact latex sits at the very top: maximum grip, maximum tackiness, and the shortest lifespan of any latex type. When raw latex sheets arrive at the factory, technicians check their thickness first. The industry standard for professional match gloves is 4 millimeters. Contact latex performs exceptionally in dry conditions, and its tacky surface also holds up well in rain. In the World Cup 2026 stadiums in the United States, where summer humidity can spike in cities like Miami and Atlanta, this all-weather performance is critical. Technicians run grip tests on every batch before the sheets move to the cutting floor. With the latex approved, the cutting phase begins. This is where raw material becomes the recognizable shape of a glove palm. Factories use precision die cutting machines, essentially industrial-grade stamping presses equipped with custom steel blade molds. Each mold is shaped to one of 3 main glove cuts: flat cut, negative cut, or roll finger cut. These cuts aren't just about aesthetics. They fundamentally change how the glove wraps around the hand and how much surface area contacts the ball. Workers inspect each cut piece for uneven edges or micro tears. Any flaw in the latex at this stage gets discarded immediately. A single weak spot in the palm can compromise the entire glove under the force of a high-velocity shot. While the latex palms are being cut on one side of the factory, a completely separate production line is building the backhand of the glove. And at the World Cup level, the backhand is no longer just padding. It's a structural system of its own. Modern elite gloves use a 3D knitted backhand material. Industrial knitting machines weave polyester and elastic fibers in a programmed pattern that changes density and elasticity across different zones of the hand. These 3D silicone ridges aren't decorative. They add punching power, stabilize the knit structure, and provide an additional grip surface when a keeper needs to parry the ball away rather than catch it. Now comes the most labor-intensive part of the process: bringing the palm and backhand together and building in the finger protection system. Assembly lines in goalkeeper glove factories are almost entirely done by hand. Skilled workers place the latex palm face down on a work surface, align the backhand panel on top, and begin stitching the perimeter seam. For negative cut gloves, this seam runs along the inside of each finger channel, which means workers stitch through narrow, curved sections with precision sewing machines set at high tension. Each finger channel gets individually stitched, inspected, and reinforced at the tip. These spines are engineered to stiffen and resist pressure when the finger is pushed backward, which is how goalkeeper fingers most commonly fracture during matches. The final construction step is building the wrist system and adding protective coatings, the last layer of engineering before the glove reaches the goalkeeper's hand. The wrist closure on a World Cup goalkeeper glove has to solve a paradox. It needs to hold the glove absolutely secure during a diving save, while still releasing quickly when the keeper needs to adjust. Most elite designs use a wide Velcro strap with a shaped wrap that distributes pressure across the wrist rather than concentrating it at one point. Before the strap is sewn on, workers apply an abrasion-resistant coating to the outer edge of the glove, where a goalkeeper's hand makes contact with the ground during a full extension diving save. Quality control is the last station on the line. Every finished glove gets flexed, stretched, and checked for seam integrity. And if a glove passes every test, it gets tagged, boxed, and shipped to a goalkeeper who will wear it in front of 1 billion people. After exploring 3 essential pieces of the modern game, one thing becomes clear. Whether it's a World Cup 2026 Adidas Samba, a national team jersey, or a pair of professional goalkeeper gloves, every product begins as raw materials and ends as something millions of fans recognize instantly. Behind the colors, logos, and match day memories are skilled workers, precision machines, and countless quality checks that most people never get to see. It's a reminder that some of soccer's biggest icons are built long before they ever reach the field. From leather cutting and heat pressing to latex engineering and final inspection, every detail serves a purpose. If you enjoyed this journey inside the factory, make sure to subscribe to Captain Discovery for more behind-the-scenes looks at how everyday products, sports equipment, and American favorites are really made. Thanks for watching, and we'll see you in the next discovery.